Firewall is any device that regulates the movement of information across networks from the outside world, known as the untrusted network, to the inside of the organization, known as the trusted network. The formal definition of a firewall is a combination of hardware and software that filters or restricts specific information from moving between the outside and the inside networks. It serves as a gatekeeper to prevent unwanted data, like malware, from reaching the inner workings of the organization. It also serves to ensure traffic goes to the appropriate destination. For example, making sure web traffic goes to the web server and email traffic goes to the email server, and so forth. A firewall may be a computer appliance, as shown here, a specially configured computer system, or an entire set of devices working together. A firewall examines each incoming data packet and makes the decision as to whether to allow it into the network or not. Other devices make similar decisions, like an internet router, and in fact, many routers have firewalls built in. The basic types of firewalls are packet filtering firewalls, which examine the header information of data packets that come into a network and determine whether to deny them or to forward them to the interior of the network based on its configuration rules. Early packet filtering firewalls were static, meaning that changes to the rule base could only be made by a firewall administrator. But eventually they evolved into dynamic packet filtering firewalls that could change or add rules based on the performance of the network and possible attacks. Stateful packet inspection firewalls. Stateful packet inspection firewalls use a standard rule base, static or dynamic, but add a special list known as a state table to expedite processing. The state table works like an express lane, tracking outgoing requests for information and matching incoming responses to fast-track them back to the requesting user. This improves the efficiency of the firewall. If an incoming packet doesn't have an entry in the state table, the firewall processes the packet through the standard rule base. Application layer proxy firewalls are capable of functioning both as a firewall and an application layer proxy server. In other words, instead of simply routing an approved packet to its destination, the application layer proxy firewall can read the request and then retrieve the information requested itself. It may also cache frequently requested information, like web pages, to speed up operations. Unified threat management devices are also known as next-generation or next-gen firewalls and are the most recent form of firewall, able to perform the work of multiple devices, such as a stateful packet inspection firewall, network intrusion detection and prevention system, content filter, spam filter, and malware scanner and filter. They can be purchased with just a few options, and then as the organization grows, additional options and features can be purchased and implemented, allowing the firewall to grow with the organization. We've also discussed how firewalls are deployed, such as the bastion host model, where the firewall is by itself between the organization's network and the internet. This is also referred to as a sacrificial host model, as the firewall becomes the primary target for attackers. The screen host architecture is where the organization places routers on either side of the firewall, configured to handle some of the basic filtering. The screened subnet architecture is where multiple devices exist between the inside and outside networks in an area of the network known as the demilitarized zone, or DMZ. Before the organization implements a firewall, they need to make sure they have policy developed and in place to regulate the operation and maintenance of the device. This involves several different types of policy, which we've defined in previous lectures, such as the organizational ISSP that regulates the use of the device, a managerial SysSP that regulates how it's configured, and a technical SysSP that contains actual configuration rules, also known as system policies, implemented into the firewall. There are several factors which should be considered when selecting a firewall. Why is the device being implemented and what is its purpose? Does this type of firewall solve the problem the organization is selecting a firewall for? What components or features are part of the base firewall cost, and what features are purchased as upgrades? What are the costs associated with the firewall beyond the initial purchase? I'll discuss total cost of ownership in more detail in the next slide. How difficult will it be for the organization to install and configure this particular brand and type of firewall? Does the organization have the needed skills to install, configure, and manage this type and brand of firewall? If not, how difficult and expensive will it be to acquire the needed personnel? What additional resources will be required to successfully deploy and use this firewall? Can this firewall be expanded beyond its initial installation and configuration? Can it grow with the organization in scope and capability? Total cost of ownership of any security technology is not just the price you pay for a piece of technology. There are other costs which must be determined. For firewalls, these costs should be considered before purchasing any firewall technology. First is the purchase price, which may differ for the same base firewall depending on additional upgrade options. Next is the annual maintenance fee. While some vendors may provide patches for problems with the device for free, others do not. Similarly, some vendors will provide upgrades for free, while others expect you to pay for them. Subscription fees for products which use specialized databases like IDPSs and anti-malware software could also be a separate fee. The organization also has to consider the cost of operating the equipment, which is much more than the cost of electricity. It includes the cost of the people to configure, run, and maintain it. If the organization doesn't have the inherent skills to configure and maintain the new technology, they must either train the current employees, which includes the cost of sending someone to training and the cost of not having that person available on site to perform other tasks. These training costs also include keeping the trained employee up to date, which could require additional training in the future. If the organization can't or just prefers not to have an existing employee trained for the new technology, it may consider hiring someone specifically for that task. There may be other costs not listed here which further increase the total cost of ownership, like insurance cost, the cost of the network racks or cabinets, and other physical infrastructure fees to house the equipment for physical devices, and the cost of virtual hosting equipment for virtual machine-based technology, plus any other overhead costs associated with the technology. In the next lecture, I'll discuss firewall configuration.